Alright, students. So with kinematic problems, I'm going to teach you the way that you should set up this problem to know exactly what formula you're looking for, what you're going to use, and then how you're going to solve for your answer. Now, kinematic problems, in order to be successful at them, we have to remember what the terms mean. We need to know what velocity means and what it is. We need to know what acceleration is and how we calculate it. We need to know what displacement is, and we need to know essentially what gravity is when we talk about gravity being a constant form of acceleration, because we will use that in problems that are dealing with linear motion going up and down or in the vertical axis. Now let's approach this problem and talk about how we would solve for this. Now I'm going to make sure I have the right piece selected. So it says a dragster going at 20 meters per second north increases its velocity to 45 meters per second north in 3 seconds. What is the acceleration during this time? Now, as always, I always say drawing a picture is your best bet. So don't make fun of my car. And I don't necessarily have to make the vector or the arrow that is signifying movement go upwards, because I can just simply make sure I write north when I write my velocity, and that lets me know that I have a speed with direction, which in turn is a vector of velocity. So if my dragster is moving this way, and originally it starts at 20 meters per second north, and I'm just going to write a capital N for north, and then it increases its velocity when it gets to another point to 45 meters per second north, and this would be my final velocity. And then it's saying in a time of 3 seconds. So how do I know that I have initial and final velocity? Well, in the statement it says a dragster going at 20 meters per second north, so that would be the initial start of this problem, and then it increases, so it has a change. It's going through a form of acceleration, because acceleration is a change in velocity. So it's increasing its velocity to 45 meters per second north. It's still going in the same direction, it's just increasing the magnitude of the speed. So I can assume that 20 meters per second north is my initial velocity, and I can assume safely that 45 meters per second north is my final velocity. And then I know that 3 seconds is time because seconds is the universal unit for time. Now I have to label my variables. You'll see that I have already did that, where I have VI is equal to 20, VF is equal to 45 meters per second, and then I have T. And then it's asking me to solve for acceleration. That's the key piece here. What is the acceleration during this time interval? Now I can look at the formulas given and see which ones might actually be something I could use when I'm dealing with these variables. And if you notice, I have VI, VF, and T, and I also have A, and I want to solve for A. I have a formula right here that I could use. So if I use this formula where I have A is equal to VF minus VI over T, I can plug in the numbers I have for those variables. So VF we know was 45, VI was 20, and again you can look at your drawing to make sure you have the right numbers in there, divided by 3 seconds. Now I have this all set up right in my formula to solve for A, which is what I'm wanting, A for acceleration. So if I take 45 minus 20, because it's in parentheses, I have to do that first, and then divide that by 3, I would get roughly 8.3, or I could say 8 seconds if I'm watching my significant figures. So my not 8 seconds, sorry. It would be meters per second squared, because the unit for acceleration is meters per second squared. Now, that would be my answer for this problem, and that would be how I would show my work. I would have my diagram, I would have my variables pulled out, and I would pick my formula and also plug my numbers in and solve for the correct answer with watching my significant figures. And how do I know I need one significant figure? 3 has one significant figure, and so does 20, because it's not followed by a decimal point. So I would only need one significant figure for this problem. Now let's look at another one, but we're using a vertical axis instead. The one we just did is a horizontal moving axis, or a linear moving motion. And this one will be linear as well, but we're talking about jumping up and down versus moving along a road, which usually when we look at roads, it would be horizontal. So with this one, it's saying calculate the hang time of an athlete who jumps a vertical distance of 0.80 meters. So I want to draw my athlete, and my athlete is jumping up from the ground a total of a distance of 0.80 meters. So jumping up, and then it's asking the hang time. Now with this one, a lot of times students get a little overwhelmed and they say, I only have one variable. How in the heck am I going to solve for anything? Well, remember, any time we're dealing with up and down or vertical motion, we always have G. Gravity is always acting on an object that is jumping up. It'll always try to pull that object back down. So I'm looking for hang time. I'm looking to solve for time. I have distance. And I also have G because this is vertical motion. Now, if I look at my given formulas, I can find one that has time, distance or displacement, and G. So I can use this formula to solve for hang time, which would be square root of 2 times D divided by G. And if I plug my variables in, because I already wrote those out, I would have 2 times 0.80 divided by, and I usually use 9.8 meters per second squared, because that's what I was taught in school. However, if you use 10, I'm not going to dock you points for that. So now, with my numbers being plugged into my equation, I can take and find the answer. So I could take 2 times 0.8 divided by 9.8, and then I could find the square root of that number. And I would get 0.4 seconds. So the hang time of this individual would be 0.4 seconds. We have to make sure we watch our significant digits. Now, the trick with this one is, technically we don't necessarily need to go off of the 2, because that's going to be a constant value in our formula. So we could actually go off of one of our 2 variables we have. Now if you use 10 as your variable for G, you would have one significant figure. If you use 9.8, we would have 2. Both numbers are 2 significant digits. So I could actually add the 0 that I calculated at the end of that. And then of course time is always in seconds. So again, drawing the picture, pulling out your variables, seeing what you know and what formula you can use, plugging your numbers in, calculating that appropriately using PEMDAS, or the rule of operations, and then making sure you follow significant digits with your number value, and then also having the correct unit. I do look for units in everything that you do. So make sure any of your numerical values that you go to calculate, you include that unit. Now again, this is a trickier piece to physics because again, we're using math. And sometimes students struggle with the idea of applying physical concepts to mathematical problems. But as long as you remember what acceleration is, what velocity is, displacement, that jumping up and down, you will always include gravity. If we have horizontal motion, we're not going to include gravity just yet. Now, if you can remember that, this can all fall together. It will take time, but again, reach out if you need help so I can help you keep moving forward.